The bench press is a multi-joint upper body exercise that is characterized by lying supine on a bench. The lifter creates a base of support with their feet, hips and legs, and another using their shoulders and head, establishing 5 points of contact between the body and the bench. The lifter then takes the bar with both arms extended at the elbow joint. The lift starts with a descending phase. By keeping the chest up, the lifter lowers the bar in the transverse plane, creating horizontal extension at the shoulder and flexion at the elbow joints. Here, the biceps brachii and the rotator cuff muscles act as an antagonist to stabilize the glenohumeral joint and the scapula, while the abdominals, glutes, and legs help to prevent excessive momentum by maintaining balance and maximizing force production. The pectoralis major, in synergy with the long head of the triceps and the anterior deltoid muscles, contract eccentrically to lower the bar at the level of the sternum or just below it. In this position, the elbow joints are at 90-degree angle. This is significant in creating the greatest amount of torque or rotational force at the shoulder joint, thereby maximizing tension and force production of the sternocostal and clavicular heads of the pectoralis major. From this position, there is a brief isometric phase where the pecs act as stabilizers, followed by a concentric or ascending phase. And the lifter presses the bar vertically. Here, vertical force starts to increase as velocity decreases, representing an ascending strength curve. This means that maximal strength and force production occurs near the top of the lift. Subsequently, the concentric phase involves a sticking region, which is a point where there is minimal velocity and therefore a higher amount of force is required to overcome the mass of the bar and gravity. Here, the coracobrachialis internally rotates the shoulder while the anterior deltoids aid the pectoralis major to adduct and flex the humerus. Finally, the triceps contract symmetrically to extend the arms until full elbow extension, marking the end of the lift. It is essential to set up the body correctly to not only minimize the risk of injury but to also maximize force production. Firstly, position yourself under the bar so the bar is at eye level. Grip width should be approximately 165 to 200% of biacromial width, with wrists and elbows stacked on top of each other. To enhance shoulder stability, retract the scapula back and down, opening up the chest. Aim to keep the feet straight and the legs at 90-degree angle to optimize hip alignment and spinal positioning. Before you start the lift, maintain a big chest by retracting the shoulders and squeeze your glutes. This will create a natural curve in the thoracic spine, increasing the pennation angle of the pectoralis major, thereby increasing force production and reducing force placed on the anterior delt. When lowering the bar, actively pull your chest towards the bar while keeping the humerus and tricep in line with the lats, with elbows screwed towards the feet at approximately 15 to 30 degrees away from the torso. Lower the bar until the elbows reach a 90-degree angle. From this position, drive your feet into the floor and hips towards your shoulders to create tension before actually driving the bar up and back towards your shoulders. Performance of the bench press can be enhanced by taking advantage of the stretch shortening cycle in the eccentric phase of the lift. Eccentric contraction coupled with 90-degree elbow flexion creates a superior mechanical advantage in the initial concentric phase, optimizing acceleration to push through the sticking region into maximal vertical displacement. Firstly, to ensure proper eccentric contraction, co-activation of the agonist and antagonist muscles requires you to actively pull the bar to your chest. This activates the upper back musculature and lats instead of just letting gravity drop the bar to your chest. A common cue that is used is to bend the bar as you pull your chest up to the bar. This cue assists to keep the elbows tucked and shoulders back and down. This not only reduces the risk of injury by creating stability around the glenohumeral joint, but it significantly enhances force output by producing optimal stretch and muscle spindle activation. Therefore, the external force applied creates a coiled slingshot effect. Effectively, this allows more significant amount of force to propel the bar upwards.